Hello, Eric Larson here. Got a new video. This is about miscellaneous topics. This is video 7 in a multi-part series. First, we have to get through the formalities. Fusion is a registered trademark of Autodesk Incorporated. It's a wonderful product. We all need to learn how to use it because it's really powerful and it's really good. Okay, this is an overview of what we're going to talk about in this particular video. We're going to talk about some basic clicking topics in Windows, and we're going to talk about some clicking things in Fusion. We'll talk quickly about how to make 2D to 3D transitions and back again in Fusion. We'll talk about how to edit sketches. We'll talk about the clicking patterns for the coincident constraints, and we'll talk a little bit about the details of marble lifter inlet design, because this is okay. So if you're in Windows, there's generally 3 types of clicks. If you do a left click, you will select something. A right click selects that thing and shows you the options for actions on that thing. A double left click says do the most common action. And generally, the most common thing you want to do is edit something. So if you're double clicking on a sketch, you'll edit it. If you double click on a dimension within a sketch, you'll edit that particular dimension. And there's never really such a thing as a double right click. Okay, let's pop into Fusion. I can show you some of those things. So here's a design. If I left click, that means I've selected this sketch. Okay, if I right click on it, it shows me all the options of what I might want to do. And the most typical things that you're going to do is you're going to edit it or you'll delete it. But you can do other things. I almost never do any of these things. If I double click on this, it will allow me to edit that sketch. And here I am. I'm now in a 2D sketch editing mode. Let's say that I double click on this dimension. I can change that from 50 to 55, no sweat. Okay, now it's bigger, no sweat. Okay, if I finish the sketch, then I'm back into a 2D mode. Now there are certain types of clicking patterns which are quite specific to Fusion. Now in Fusion, if you look at the browser is your thing on the left side of the screen. You can hide it or expand it. The first thing that you will notice is that you have a caret here. That's this triangular thing. All right, let's see how. All right, hang on. Okay, let's just move this. Yikes! I didn't want that. All right. Okay, let's move this over slightly. Okay, cool. All right, what we see is we have this caret, which is the triangular thing, and if you click on it, it expands the list of things that are visible underneath that heading. If I click on bodies, you can see I have 2 different bodies. I have a number of sketches that I can view. If I look under construction, you'll see that there are various planes that are part of this design. Okay, that's the caret. Okay, the eyeball turns on and off visibility for various things. If I click on the eyeball for bodies, it causes the bodies that are visible underneath the bodies heading to disappear. Now maybe I want that marble. This is the marble. Maybe I just say, hey, I don't want to see that marble. I can turn it on or off, and I can turn on and off the trough here. That's an example of what you can do with the eyeball. If I turn off the let's say that I have this knob here. Let's say that I'm just not interested in that for a few minutes. I can just turn it on and off by clicking the eyeball. Okay, that's the eyeball. So generally, for anything that you might have, you have the caret, the eyeball, and the icon. If I click on the icon, and double click it, that gives me the most common thing. If I double click on this one, it edits the sketch. Okay, finish the sketch, get out of that. Okay, the other thing that you have is typically the name. So in this case, the sketch is named base feature, and I could rename that to be something such as base. If I type in something, I might call it base feature sketch instead of just calling it base feature. But it's important to name your objects if you start having a bunch of them. You know, I'm looking at this, I'm going, wow, what is sketch 11? I just don't remember what it is. Well, if I had named it something reasonable, then it would be clear on that. So sometimes you have to turn on the top level eyeball to be able to see what the underlying things are. And if I look at this, I can see that this sketch is something to do with this basic area. You know, it's here. You know, I can turn it on or off if I don't like it. All right, so those are the things that are specific to Fusion. You have the caret, the eyeball, the icon, and the name of things. So the caret, eyeball, icon, and name. All right, let's pop back into our slides. Okay, we talked about Windows clicking. Right, back to slideshow. Okay, we talked about Fusion clicking. Just, you know, the caret, the eyeball, the icon, and the name. It's important to rename things so that they're meaningful. Okay, editing sketches. What you want to try to do is you want to have only one sketch at a time visible to avoid confusion. And when you're editing a sketch, you generally want to turn off visibility to bodies. That's generally true, but not always. And you always want to do the editing normal to the sketch plane. It's possible to edit things at an angle, but it's almost never the right thing. So let's pop back into Fusion, and I can show you what I mean. So let's just go to something a little bit simpler. Here's a study. Here's a sketch. We'll turn on this base feature sketch, and we'll edit it. Okay, so it's in this case we're editing normal to the sketch plane, and all of our bodies are turned off. But if we go up to the right here and click on our doghouse, or the home icon, you can see that now we're viewing this sketch at something of an angle. And we can still edit it from here. You know, if I double click on this dimension, I can make that 22 instead of 21. But I really want 21. You can see that we can edit a sketch when we're viewing it at a kind of a weird angle. But it's almost always better to edit it from the correct perspective. I guess in this case it would be a top view. All right, finish the sketch. All right, back to our normal view. Okay, that's what we want for sketches. And like I said, you almost always want to have only one sketch visible at any given time. And generally, if you're looking at a three-dimensional object, you want to turn off sketches. You know, if sketches are visible, it just kind of makes for a cluttered view. So I generally click the icon, turn off the sketches. Okay, back to our slides. View the slideshow. Okay, editing sketches. All right, that's pretty fast. All right, now let's talk about the coincident constraint. So this is used to fix a condition where you do not have a closed profile. So what you want to try and do is make 2 points occupy the same coordinates, and generally this is used to close up something that is open that should be closed. And a closed profile is one where you can go all the way around a continuous continuous line and get back to your starting point. So the coincident constraint needs 2 points, but the clicking pattern for that is some sort of complicated. And you can select one or both of the points before you activate the constraint command. And there is also a shortcut for constraints, and it also might fail if things are locked down. So let's go back to Fusion, and I can show you what I mean. All right, back to Fusion. All right, Fusion. All right, where is my... Okay, here is a sketch that I have created which kind of illustrates the problem that we might have. So let's say that these 2 points are obviously not coincident, and we want to fix that. So what we might do is select one of the points and then pull down Constraints, Coincident, and now it wants us to select the second point. If we click on it, wow, now it's fixed. And what you see is that it made those 2 points occupy the same space. Now we have a closed profile. We hit Escape, say we're done with it, and we can click here and get a closed profile, which we could not do before because it wasn't closed. So let's undo that coincident. All right, now we're undone, and let's see a situation where it would fail. Now this dimension is a driven dimension, and we will change that to be driving. And so if you compare these 2 dimensions, one of them is surrounded by parentheses and the other is not. This is a driving dimension. It's saying we want to force this line to be 30 millimeters above the origin. And this dimension is driven. It's saying that we can have that to be about wherever we want, and it just happens to be 20 at the moment. So if we select this point and try to drag it, we can drag it up and down, and you can see that the dimension changes. Okay, if we select this point and try and drag it, we'll see that it doesn't work. It just says, sorry, I can't do it. I'm forced into having it be at a dimension of 30. So if we right-click on this dimension and make it into a driving dimension and force it to be 19.532 and try to apply a coincident constraint, it will fail. So if we pull down coincident and select this point and then this point, we will see that we get an error. It says fail to solve. Please try revising dimensions or constraints. So it won't do it because we're forced into something that says, hey, it won't work. So if we change this to be a driven dimension and then try the coincident constraint again, it should work this time. Okay, we'll click here, cool. Now we see that we now have a closed profile. We're both at 30, no sweat. So we can undo that and just kind of talk about the pattern of clicks. Now in general, Fusion is pretty flexible. It allows you to invoke the constraint command without having selected anything beforehand. And then we select these 2, it's done. Okay, the other way that you can do it, okay, undo coincident, is that you might select one point before you select the coincident constraint, and then if you select the second one, then it's done, no sweat. Okay, hit escape, undo coincident. The other thing which you could do is you might select them both. I've selected the first one, I hold down the control key, I select the second one, and we see here that 2 sketch points have been selected. If we pull down constraints, say coincident, there it's done. So Fusion is pretty flexible in the pattern of clicks. And the other thing about the coincident constraint is that you have a nice shortcut here that it's just faster to click here than it is to pull down constraints. And so we go click, click, done. No sweat. All right, finish the sketch. We're all done. We can pull out here. We click here. We see that we have a profile. If we hit E for extrude, we could extrude this profile, and it would be really cool. Okay, very nice. Okay, that's the coincident constraint click pattern. Okay, back to video, back to our slideshow. Okay, we talked about coincident constraints. So now let's compare a couple of different design studies for our marble lifter. So I've created two different designs here called studies F and G, and we designed F in video 6. And this design has been built and it works. It picks up and recycles actual steel marbles. However, study G is just something that we made, just as an example, and it might not work. So before you build it in an actual 3D printer and waste a lot of filament, I suggest you try and make a small version of it and see if it actually works. So let's go back into Fusion and look at study F. Here's study F, and I've inserted the spiral element of this case. So this is a simple one-channel machine, and if you look at the orbit, you will see that the inlet comes in from one side. If we click on front and then view from the side, you can see that it has a sloping inlet pattern. And if we rotate back, you can see that the inlet splits the channel. If we go to the top, we can see that this is our channel, and our inlet splits the channel and delivers the marbles into the channel from the side. All right, so we can save this, hit save. All right, let's look at study G as an alternative. And in this is something that's got a different design, and what you'll see is that the inlet orifice comes in directly from the side of the channel. And it is not clear to me that this design will actually work to pick up marbles. And so before you build a large-scale thing that uses this design that comes in from the side, or comes in, I don't know, tangentially to the channel, you might want to prove it to yourself by building something small and see if it actually works. You can see, this is going to deliver marbles into the channel from one side, and I'm just not sure that it's really going to work. I think the marbles will kind of get stuck or not get lifted properly. And you can see that I added the spiral element to this design just to make it a little bit easier to look at. Okay, back to the slides. Okay, and again, just to reiterate, some designs have been proven to work and they kind of make sense, and other designs might not work. So try it. So here's a recap. What we talked about in this video is basic clicking in Windows and Fusion, 2D to 3D mode transitions, how to edit sketches, the click pattern for the coincident constraint, and a discussion of marble machine inlet design. So that's all there is to this video. I realize this one's getting kind of long. It's 19 minutes. So we will hit the pause button and say that that's all for this particular episode. All right, catch you later. Eric Larson signing off from Silicon Valley.